Hello, I'm Zach with Chegg Tutors, and this is a video that's hopefully going to explain how to find volumes of revolution using the cylinder method. So the cylinder method is similar to the disk method and the washer method in that we're looking at cross sections. In this case, the cross sections happen to be, this is not a perfect drawing, happen to be cylinders. Alright? So in order to, what do? We integrate the area of all of these cross sections to get the volume. So the first thing we need to do is figure out what's a formula for the area of a cylinder. Okay? We're not filling this in, it's just a tube, if you will. Okay? And the formula involves a couple things. Okay, it involves the height, it involves the radius. So the formula for the area of this cylinder is 2 pi r times h. Now, if you want to make a cylinder of your own, you can test this out by cutting the cylinder and then unfolding it. And what you end up with is a rectangle, sorry. That's a poorly drawn rectangle. What you end up with is a rectangle whose height is h and whose length, whose width, is the circumference of the circle that is at the base of the cylinder. So we'd like to integrate those. So we'd integrate from a to b 2 pi times r times h. And then we'd either integrate dx or dy depending on which axis we're cutting perpendicular to. So let's do an example. Alright, one that I've set up already. And so what do we have here? We have a shape that should be familiar to you if you've seen my video on the washer method. Right? So we should get the same answer that we got there. Here we're rotating around the y-axis. So what do our cylinders look like? Let's get a picture of those. They look like this. And let's make that black. And I'm going to need another one of those. I'm going to need to move it. Give me 1 second here. Never mind, I'll just delete that one and put another. Alright, that was acting a little bit fiddly, so I took a moment to set it up. We're okay now. And so what do we have? Our formula for integrating with cylindrical cross sections looks like this. The integral from a to b of 2 pi rh dx or dy. Now we're taking these cross sections, they're coming straight down. Okay? So they're perpendicular to the x-axis. So we want to integrate with respect to x. Okay? They start here down at 0, x equals 0, and they go all the way over here to x equals 1. So our a and b are 0 and 1. We have 2 and pi. And what's r? Well, r is right here. Okay? So r is the x-coordinate. It's measuring how far away we are from the y-axis that we're rotating around. So that's r. But what about h? Well, h is, let me use a different color so that it shows up. H is right here. Okay, h is the difference between this height on this square root function and this height on y equals x. So we need to take a difference for that, and what we're going to get is the square root of x minus x dx. And if you integrate all that out, what you're going to get is 2 pi over 15, just like in my previous video where we used the washer method. Okay? What if we rotate around the x-axis? Alright, so we have this set up here. We're integrating from y equals 0 down here to y equals 1 up here, and our cross sections are coming in from right to left or from left to right, however you want to visualize it, but they're horizontal, right? The cylinder's on its side, so that means that we want to integrate with respect to y. Okay, so we have 2 times pi times the radius. Well, what's the radius here? The radius, excuse that for a second. The radius is right here, and that's the y value that we're looking at. Okay, that's because the y value is measuring the distance of this cylinder from to the x-axis. Alright. And what about the height of the cylinder? Well, again, we're going to have a difference here. The difference in the x value of this point. So here's that x value down here, and the x value of this point. Well, to do that, we're going to have to solve these equations for x, and what we get is that x equals y squared. And this one's already solved for x in some sense. So what we end up with is y squared minus y. Good? Yep, good. That's what I got. And so if you integrate this, what you end up with is 1 over 6 pi, just like before in our previous video. Okay? So I hope that helped y'all. Cylinder method is very useful. Sometimes it's one of the harder to get used to right off the bat, but it's worth it. Best of luck.